Alright, this is solution for number 1 in the FRQ test. Number 1. Fish enter a lake at a rate modeled by this function, and fish leave the lake at a rate modeled by. So this is an example of the classic College Board classic. Some things are coming in and some things are going out, and we have the rate functions for both of those. Both the rates coming in, going out, are measured in fish per hour, and T is measured in hours since midnight. Okie dokie. How many fish enter the lake over the 5-hour period from midnight to... Okay, so this is just there, getting us warmed up here. If we want to know how many enter, then we just have to take the integral of the enter rate function from 0 to 5. And that is all you need to do. They're not asking how many fish are in the lake. They want to know how many entered. That is just the integral of this, or the area under that. Alright, you could either, it's not a bad proposition here to put the enter and leave functions to y1 and y2. You can do that if you want. I'm going to go ahead and do that since I'm talking about it. I'm going to hit the sign function button, so every time I do that, I'm going to just double check, make sure I'm in radian mode. I happen to know that this calculator is, but set a good example. Radian mode. And then I'm going to put the leave function in here, so 4 plus 2 to the, 2 to the 0.1 t squared. That looks good. Okay, now back on my home screen, what does that do for me? Well, I have them in as y1 and y2 now, so when I do my math 9 from 0 to 5, I can just type from the variables menu, that vars key, and bring that up, dx. And that looks like, am I supposed to round here? Measured in, give your answer to the nearest whole number. Yep. And that's 153 fish. Rounded to the nearest whole number. Alright. B. What's the average number of fish that leave the lake per hour? So that's the average of the leave function. So how do you find the average value of a function? You do the integral from wherever to wherever, 0 to 5 in this case, and you divide by the width of the interval. And that's the average of the leaving function, so the units are going to be fish per hour for that. So I can do the same thing here. I'm going to go math 9, 0 to 5, and except this time I'm doing the leave function, so that is y2, and I'm finding the average value of it, so I'm going to divide by 5. That's 6.059. Fish per hour. Number C. Just kidding, that's a letter. Well, I guess this is a math class, so it could be a number 2. What time T between 0 and 8 is the greatest number of fish in the lake? That seems grammatically odd, but I think it's actually correct. I'm sure the College Board has people who check that sort of thing out. So we want to know when is the number of fish in the lake at a maximum. Okay, so I think the first thing I need to do is find, I'm going to make a number of fish function. The number of fish as a function of time is equal to, are there any fish, usually the lake, I guess it doesn't matter how many fish are in the, because when I take the derivative of this, So I could just put in a constant here, like the number of fish at time 0. That's just some constant. I'm going to put it there because if I'm really going to claim this is the number of fish in the lake, I think we can't actually do that, can we? Because we don't know how many there were to start with. But it's not going to matter for us because I used the t in 2 different places. Really, this should be an x or some other letter. If you want to know when the number of fish in the lake is at a maximum, you set the number of fish, the derivative of that, equal to 0. And when I take the derivative here, that's just a constant, so it goes away. So I realize that, oh yeah, it makes sense that when the enter and the leave function are equal to each other, that is the critical point. Because if there's more entering than there are leaving, then the number of fish in the lake is increasing. And if there's more leaving than entering, then it's decreasing. So the crossover point is when they're equal to each other. So let's find where they're equal to each other. So I've got them both graphed here. I could do window from 0 to 8 because that's all I care about here. And let's see, -10 to 10, that is probably not going to cut it. This is going to max out at like 35, so maybe like, I don't know, I could go from like 0 to 40. Probably be okay. Right, I'm just looking at this. That's a trig function, 20 plus 15, that's the amplitude of that, so going to max out 35. There it is, maxing out at 35. So that's fish entering. Here's fish leaving. There's where they intersect. That's what I'm interested in. Second, calculate. Find the intersection there. I only have 2 curves in here. So first curve, second curve. And yep, there's our little cursor there. So that happens at t is equal to 6.204. And I'm looking for the maximum on a closed interval. So I'm going to move over here and find the time here. So I've got 0 and 6.204 and 8. All right. So, and this is the number of fish in the lake. I guess we're just supposed to assume that that's 0 at the start. It didn't tell us anything about that, so we'll just go with the 0. And if you want to know how many fish are in there at time c, then I just need to do that, right? So I'm going to go back to my home screen. And I'm going to figure out what is the integral of the enter minus leave from 0 to this, and then I'll do the same thing with 8. And I should be able to use, this is where the calculator, being good with your calculator, can save you lots of time. So 0 to 6.204, and then here I want the enter function minus the leave function. Dx. So about 135 fish there. And then I can just copy that. I'm going to do second entry. That brings me up another copy of that I can work with. And I'm going to delete this stuff here and just put an 8. Saves me a little time. And it's about 81 fish. So maximum. Now, are they asking for the number of fish or the time? At what time? So they want this. Max. You can always cover your bases and just make sure that you're giving the right answer. You could say max of 135 fish at time 6.204 hours. Then you got them both. So whichever one they were asking for, you got it. Part D is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m. Well, is the rate of change in the number of fish in the lake increasing or decreasing? So that's really asking, that's kind of like a second derivative, but these two things here are themselves derivatives. So the rate of change of fish in the lake overall is enter minus leave, right? So if you want to know if that's increasing or decreasing, then you'd find r prime and look at the sign of it. So we want to know what's e prime of 5 minus L prime of 5. Okay, there's different ways to do that. I'll show you one here. Since we have both of these things graphed, I could go to, let's see, second, calculate the slope, so dy dx, number 6. And you can see which function you have here. If you toggle up and down here, you can switch between your y1 and your y2. So for y1, I want to know what is the slope at 5. I type that in there, and it gives me the slope. That's negative 6.802 minus L prime. So I'm going to do that again. So I can calculate the slope. I'm going to go down to this curve and do it again at 5 is 3.921. So that is definitely negative. So it is that is less than 0. So the rate is decreasing.